Hello, everyone, and welcome back. In today's data rich world, organizations collect vast amounts of information every second. But how do you take all that raw operational data and transform it into meaningful insights for strategic decisions making? How do you answer questions like what were our top selling products last quarter across all regions were, and also and something like what our best searchable products in our e-commerce. The answer lies in data warehousing. In systems and interviews, demonstrating an understanding of data warehousing is crucial for discussing analytics, reporting, and business intelligence systems. Today, we are diving into what a data warehouse is, why it is vital, and its key characteristics. Okay, so let's try to understand the problem first. Our every operational databases, our everyday operational databases, like those powering your e-commerce websites or even your banking app, are optimized for OLTP, online transaction processing. They handle frequent small transactions, fast reads, writes, and updates efficiently, okay? But they are not designed for complex historical analytics query. If we have operational database limitation, they have some limitations like running a complex query like calculate the average customer lifetime value across all products purchased in the last 5 years. This is quite complicated to create a query like that. Um, this this segment by Riffler source directly on your live operational database would likely take forever to be completed. Also, it will consume massive resources, potentially slowing down or even crashing your transactional system. Also, we have some problems like the disparate data sources. Furthermore, like critical business data often lives in many separate operational systems across organizations. Also, we have the need for aggregation, like business users need summarized, aggregated, and historical views of this data, not raw transaction details. This creates a clear need for a separate, optimized system specifically built for analysis. Okay, okay. So right now we understand the problem. We have operational database limitation. We have some disparate data sources. We need aggregation. We have this need for aggregation. Because of that, we need to use data warehouse. But what is a data warehouse? So, a data warehouse is a centralized repository of integrated historical and subject oriented data, specifically and especially designed for analytical reporting and business intelligence. Okay, so let's talk about the analogy. So if your operational database are like registers processing daily sales, a data warehouse is like a maliciously organized, specialized research library designed for historical and strategic research. It's not for day-to-day transactions, but for deep analysis. The idea here, we have the key idea is with something called schema on write. It unlike data lakes, as a data warehouse impose a strict predefined schema before data is loaded. So if you watch the previous video when we talk about data lakes, we have schema on read, but the data warehouse have a schema on write, and basically that means there is a strict predefined schema before data is loaded. Data is transformed and cleaned to fit this schema, ensuring high data quality and consistency for analysis. Okay, so let's talk about data warehouses. Not data houses, the key characteristics of data warehouses. First, we have a subject oriented. Data is organized around core business subject rather than around the operational process that generated this or then generated it. This makes it intuitive for business analysis. What is a business subject? Something like customers, products, sale, marketing campaigns, things like that. Number two, integrated. Data is collected from various disparate operational sources like ERP systems, CRM systems, web logs, sales systems, all of that. It's then cleaned, transformed, and harmonized into consistent format and structured within the warehouse, resolving inconsistencies and ensuring uniformity. Number three, we have time variant. Data includes a time element allowing for historical analysis. Data in the warehouse is stable after entry and represents information at a particular point in time. This enables trend analysis, comparison over periods, and forecasting. Number four, which is non volatile. I always mispronounce it. So it's volatile. Volatile, I guess. Okay, let me try to pronounce it in the right way. Yeah, volatile. Yeah, I said it right. So again, once data is loaded into the data warehouse, it's generally not updated or deleted. New data is appended incrementally. Okay, this ensures a stable historical record for reliable analysis. Number five, we have schema design. Data warehouses are highly structured, commonly using specialized schema design. Like there is fact table, like this contain quantitative measurable data and foreign keys that links dimension tables. Like example, we have sales amount, quantity sold, things like that. Also, there's a dimension table, or which will contain a descriptive attributes related to the facts. There is a star schema, which is the most common one, I would say, which is a central fact table is surrounded by a denormalized dimension tables. It's simpler to understand and query and generally faster for joins. There is also a snowflake schema, which is a more normalized version of the star schema, where dimensions themselves are normalized into multiple tables. It saves storage but can involve more complex joins. Number six, we have ETL processing, which is the extract, transform, load process. This load process is absolutely critical. It's the mechanism that extracts data from operational sources, transform it to fit the warehouse's schema, and loads it into the warehouse. ETL jobs are often complex and run in batches. Also, we have querying and BI tools or BL tools. Data warehouses are basically accessed via SQL interfaces and powerful business intelligence (BI). BI tools like I guess Power BI and Locker. I guess there are two things like that. But you don't need to know that. You don't need to know that in context of systems design review, I would say. And if you want to know example of modern data warehouses, I guess we can talk about Amazon Redshift. It's yeah, and also Google BigQuery. This is the biggest one, Google BigQuery. Okay, so why? Um, yeah, yeah. Why data warehousing matters in system design. Number one, for business intelligence and strategic analytics. Like it provides a single consistent source of truth for making informed business decisions, understanding trends, and forecasting. Number two, in performance for complex queries. Here, it's purpose built for fast analytics queries across vast historical datasets without impacting live operational system. Number three, data quality and consistency. The rigorous ETL. I guess I pronounce it right as well. Yeah, rigorous. The rigorous ETL process ensure high data quality. If you don't know what is rigorous, it's something like I would say the strict ETL process ensures high data quality, which is paramount for reliable insights. If you want to talk about also, it's a great in historical analysis because it enable in-depth analysis for long-term trends, customer behavior patterns, and historical performance. It's great in decoupling because it cleanly separates analytical workloads from transactional systems, preventing resources connection. contention, not connection, contention. Sorry. And lastly, something about interview focus. I would say discussing data warehousing shows your understanding of how organizations extract value from data, build like BI capabilities, and manage analytical workflows. Lastly, we will talk about some challenges. So while it's a quite powerful, data warehouses has its own challenges. The first one, which is the rigidity and schema challenges or schema changes. So the predefined schema can be quite rigid, making changes to the schema can be quite complex and costly. It's really complex. It's not just quite. Also, we have upfront ETL effort, like designing and building robust ETL pipelines require significant upfront effort for and ongoing maintenance. Also, we have a problem with latency because data is typically not real time. It's usually how hours or even days old due to patch ETL process. But I guess this is not a problem because this is what warehousing actually about. They are not designed for day-to-day use, so the latency is not a big challenge, I would say, but it's something you need to discuss in your systems interviews. Also, we have some storage costs because storing large volumes of processed structured data can be really expensive. So yeah, that's it for this video, and yeah, that's it, and see you in the future, guys.